The region D above can be described in two ways. Number one, if we visualize the region having top and bottom boundaries, express each as a function of x and provide the interval of x values that covers the entire region. Just notice how the top boundary of the region D would be this horizontal line here, which has an equation y equals 3, and the bottom boundary would be this line here passing through the origin. Let's work on determining the equation of this line here. We'll notice how it passes through the origin, which would be the ordered pair 0, 0. It also passes through this point here, which has the ordered pair 5, 3. So notice how this line has a y-intercept of 0, and using these 2 points, notice how the slope would be up 3, right 5, and therefore the slope is 3/5. So the equation of this line would be y equals 3/5 x, which means the top boundary, g sub 2 of x, would be y equals 3, and because g of x equals y, we can say that g sub 2 of x equals 3. Next, the lower boundary is a line y equals 3/5 x, which means our function g sub 1 of x would be g sub 1 of x equals 3/5 x. The interval of x values that cover this region, notice how it would be x equals 0 here, all the way out to this point here where x equals 5, and therefore the interval of x values that cover this region would be the closed interval from 0 to 5. Now let's take a look at number 2, where we define this region using left and right boundaries. If we visualize the region having right and left boundaries, express each as a function of y and provide the interval of y values that cover the entire region. So notice how the right boundary would be this line, which we know has equation of y equals 3/5 x, and the left boundary would be this vertical line, x equals 0. But notice how we do need to express these as functions of y, not as functions of x. So for the right boundary, we know it is y equals 3/5 x, but to express this as a function of y, we need to solve this for x. To do this, we would multiply both sides by 5/3. We would have 5/3 y equals x, which means our function f sub 2 of y would be 5/3 y. Next, the left boundary we already know is x equals 0. Because f of y equals x, we can say f sub 1 of y equals 0. And then finally, the interval of y values that cover this region, well, notice how this low point here has a y value of 0, all the way up to this horizontal line, which is y equals 3. And therefore, the interval of y values that cover this region would be the closed interval from 0 to 3, again for y values. Being able to define regions in the xy plane using both of these methods will be important when we start setting up double integrals when determining the limits of integration. If we integrate with respect to x first and then y, we would use the method we used in number 2. If we integrate with respect to y first and then x, we would use the method we used in number 1. I hope you found this helpful.